All right, what we have on this particular paper is Chem 412. Chem 412 is actually the course code. Then the title of the course is Reaction Kinetics. It's a branch of chemistry, so it's a chemistry subject. Let's look at the question we are going to solve this morning. Calculate the activation energy. Okay, see what I'm going to do. While I'm reading the question, I'm going to interpret the question as well. So let's look at the solution. Calculate the activation energy. Now, activation energy is symbolized with a letter, capital letter A and a capital letter E, and a small letter, the small letter A. All right. Say calculate the activation energy for a reaction. Now, activation energy in this case is not known. Okay, since it is not known, so I use a question mark. For a reaction whose rate constant at a room temperature. Now the room temperature is 25 degrees Celsius. So I'm going to write my temperature 1. My temperature 1 equal to 25 degrees Celsius. Remember, they say room temperature. So I'm going to convert this 25 degrees Celsius to Kelvin. So if I do this, I'm going to have my 25 plus 273, and this will be equivalent to 298 Kelvin. This is my temperature 1, the room temperature. So the next thing I have in the question is, they say for a rate constant for a reaction whose rate constant for a reaction whose rate constant at room temperature, we have done the room temperature, is double. That means rate constant in this case is double. For question I, the rate constant is double. So if the rate constant is double, it means there must have been the first rate constant that makes the second one to be double. So for the rate constant, for a rate constant to be double, it means there must have been a first rate constant that makes the second one to be double. So now first rate constant, which is this K stands for the rate constant, is equal to K. So the second one now, according to the equation, which is the rate constant 2, will be equal to double of the first one. Now double of the first one, okay? After knowing this, they say, continue the question, they say, okay, II is triple rather, okay? So for all by a 10 degrees Celsius increase, that means you have been given the temperature 2. I've been given temperature 2. So in this case, my temperature 2 is an increase of temperature 1 by 10. That means for temperature 2, they say all by a 10 degrees Celsius increase. That means the room temperature is increased by 10. The room temperature is increased by 10 in that case. So that my temperature 2 is, remember the room temperature was 25 degrees Celsius. So it's increased by 10 degrees Celsius. And this makes it to be all equal to 35 degrees Celsius. So convert this to Kelvin. It's going to give you 308 Kelvin by that, which is 35 plus 273. It will give you 308 Kelvin. Once you have this, you are doing well. Let's check more. Now what you need to do in this case is, you are now going to apply the formula to do this. So using the formula, now the formula is activation energy equal to R times log K2 over K1 times T1 times T2, okay, times 2.303 all divided by T2 minus T1. Once you have this formula, you are doing well. So let's substitute these values here into this formula. By the way, remember, note that my R is a constant. Is given by 8.314 joule per Kelvin per mole. That's it. So I'm going to substitute all these rubbish rubbishes into this formula, and so I have my R 8.314 times my log. What's my K2? My K2 is 2K. All of my K1 is K. Times what's my T1? My T1 is 298 times my K2 is 308. Okay, times my 2.303. I can choose to use this divided by what's my T2. My T2 is, which is temperature 2, is T2 is 308 minus 298, which is my T1. Okay, once you have this, you are doing well. Okay, you are doing well. If you use your, I'm going to cancel something here. My K can cancel K. You see? So now I'm going to multiply 8.314 times 298 times 308 times 2.303. So if I do this, what I am going to have is one, that is by using your calculator, 175,7401.281. Okay, now times log, remember log 2 is left, all divided by, can choose any of the two, all divided by 308 minus 298 is 10. So remember, 175,7401.281 times log, what is log 2? Log 2 is 0. If you use your calculator, 0.3010. Okay, still divided by 10. Now if you multiply this by this, what you are going to have is nothing but 7856 divided by your 10. Remember? So now if you divide this by 10, what you are going to have is nothing but 52,897.78. Divide this with your calculator, you are going to have this. So once you have this answer, this is the answer in joule. You can stop here, but if you choose to take your answer to kilojoule, then you divide this by 1000. If you divide this value by 1000, what you are going to have is 52.9 kilojoule. This is your activation energy when the rate constant is double. This is your activation energy when your rate constant is double. Do you understand it? So now let's check when the rate constant, according to question II, when the rate constant is triple. So when the rate constant is triple, that means you are going to have your K2 K2, you're going to have your K2 equal to triple. You see, the other one was double. So when it is triple, you're going to have your rate constant to be this way. So the same thing, by applying this formula, by applying the formula, this same formula. So I'm not going to waste any time here. I'm believing you understand what we did here. So I'm going, the only difference between this particular question and this question number II is the rate constant. See, is the rate constant. This one, the rate constant is 3, but here it was 2. Okay, so I'm going to substitute 3k into this, which is in this place. So everything being equal, except the rate constant 2. To see what I'm going to do, so everything falls within here. This is where we are going to have the 2. If I put the 3 here, 3k over k, which is 3k over k, k will cancel out k, and 3 will be left. That means everything is equal. Everything is the same except the 3k. So I'm going to have my rate constant EA equal to everything being the same except this. So I'm going to have 1757401.281 times log 3. The other one was 2, so we had log 2. Since this one is 3, we are going to have log 3. Everything being constant, okay? Everything being the same. All divided by the same 10. So by doing this, I'm going to have 1757401.281 times what's log 3? Log 3 is 0.4771. Use your calculator, divided by 10. So by multiplying this by this, what you are going to have is going to be 838,456.15, still divided by 10. So this will give you, if you divide this by 10, it's going to give you 83 83845.62. Use your calculator. So this is the answer in joule. So in kilojoule, just divide this value by 1000 and you are going to have nothing but 83.8 kilojoule. This is the value for the rate constant. Value for the activation energy when the rate constant is triple. Value for the activation energy when the rate constant is triple. Okay. Now this is the value for activation energy when the rate constant is double. Do you understand? So it is simple. So I'm sure you don't have any question to ask, but if you do, feel free to use the comment section to ask your question. I will be here to help you out.